Section 11.5, temperature and pressure. This is also known as Gay-Lussac's law. Again, don't care. The pressure of a gas is directly related to the temperature of a gas in Kelvin. Okay, so again, we got this Kelvin. We see this idea of P1 T1 equals P2 T2. So if I was going to show, actually they usually show it like this. If I was going to show this relationship before, it would be the pressure is proportional to the temperature times some constant K. Solving that for a more useful equation. Here's the pressure and temperature at some time. Here's the pressure and temperature at some different time where we have changed something about that gas. Okay? Now, let's introduce this idea of vapor pressure. Right? So here's what we have. Here's a beaker, right? And here's that beaker's full of water. Okay? Now, we know already that molecules are going to escape that water, right? They're going to evaporate off the surface. Regardless of the temperature, it's going to evaporate off the surface. Well, what happens if we take that container, that beaker, and we put it into an enclosed system? At a certain point, those particles will collide against the side of that container. Well, that creates pressure. Where did that pressure come from? It came from the vapor. Now, what is a vapor? A vapor is a gas from a substance that is a liquid at room temperature. Okay, so that's the difference between a vapor and a gas. A vapor comes from a liquid at room temperature, where a gas at room temperature is just a gas. Okay. So as I said, those the molecules will evaporate. Okay, and at some point they're going to exert pressure by colliding against the side of the container. Now we also know that if we increase the temperature of this water, if we increase the temperature, more particles are going to be able to evaporate. Right? Since more particles can evaporate, that's going to increase the vapor pressure. So the higher the temperature, the greater the vapor pressure. Now there's usually something called a vapor pressure table, which is this right here. You don't have to memorize this kind of stuff. And we'll use this in AP. We'll do a lab where we have to take out the vapor pressure, but generally we don't do too much work with that here your first year. Now, what is boiling? Okay, boiling is a process, and that's very important to remember. Boiling is not a temperature. Boiling point is a temperature, but boiling is a process. When the atmospheric pressure is equal to the vapor pressure of the liquid, that's when boiling occurs. So boiling can occur at any temperature, right? So take a look at this vapor pressure of water. Let's look at 60 degrees Celsius. Vapor pressure is 149 millimeters of mercury. If I can make the atmospheric pressure equal to 149 millimeters of mercury, water will boil at 60 degrees Celsius. So boiling is a process. Boiling is not a temperature. Boiling point is a temperature. Okay? Now, how does a pressure cooker work? Well, what a pressure cooker does, let me draw a pressure cooker, my fancy picture here. So here's a pressure cooker. They're usually clamped on. They have these little clamps like that. So what happens is you got a little bit of water in here, and you got this clamped on. All right, so this lid can't come off. And you apply some heat, that's supposed to be flames, and the water then starts to evaporate, right? And it creates pressure, right? So that's creating pressure. Well, that is increasing the atmospheric pressure. So if we look up here, you can see at 760, which is 1 atmosphere, the boiling point of water is 100 degrees Celsius. If we increase the pressure to 800, the boiling point goes up. If we increase the pressure to 1075, the boiling point goes up to 110. Why would we want to do that? Because it's the temperature of the water that cooks the food, not the action of boiling. Like if I put a couple eggs in to boil at 60 degrees Celsius, it's going to take forever for them to boil, for them to become hard boiled, and they may never will. I don't know the exact temperature where it actually happens, but if we increase the temperature, if we're able to increase the temperature, the food is going to cook faster. And again, that's because we're increasing the pressure that's directly over that liquid. All right?